I'm Staumont from the University of Liège. As part of the European project Ontox, our team is working on the development of what we call physiological maps. With this video, we would like to introduce this concept to you to explain what is behind this term, how it works, and why to build such maps. Ontox is a project that has been funded by the Horizon 2020 Research and Innovation Program of the European Union. Ontox brings together 19 partners around the world to develop alternative methods to predict the toxicity of chemicals, avoiding the use of animal testing. And one of the specific objectives in Ontox is to build what we call the physiological maps. It is the concept that we want to illustrate in this video. If you would like to know more about Ontox, please check the Ontox website here and hold this video on YouTube. Like any other map, such as the ones represented here, the Ontox physiological maps represent relationships between elements of some space. However, with physiological maps, you will not navigate between cities and countries, such as in Google Maps, for example. Physiological maps will rather depict connections between genes, proteins, and other molecules. They graphically represent biological mechanisms, in particular the physiology, that is, the normal function of certain processes. In other words, physiological maps represent biological systems and networks of interacting components such as genes, proteins, and metabolites, with each component represented as a node in the network and the interactions between components represented as edges between nodes. In the Ontox project, we focus in particular on some functions in the liver, the kidney, and the developing brain. Building such physiological maps requires several steps and is a continuous process. First, we need to clearly define the purpose and the scope of the map to be designed. During this preparation or planning phase, we established a list of people who will work on the map, which means the map developers, but also the domain experts to work with. Together with the experts, the developers also set the boundaries of the map by listing the different modules and the biological pathways that we aim to include in the physiological map. Needless to say, the domain experts play key roles all along the process. In the next step, they notably had to collect the relevant data. These data can come from a variety of sources like scientific articles, books, or online databases. And data collection can be done manually or in a more automated way using data collection tools such as the ones we are developing in Ontox. After data curation, including, for example, annotation and quality check, we can start creating the map using the Cell Designer software. These tools allow you to graphically represent the networks of proteins, genes, and other molecules. And if you would like to know more about how to use this software, stay tuned as we will soon release a specific tutorial on how to use Cell Designer. As you are using Cell Designer, the physiological maps are encoded in a particular computer language called SBML. SBML stands for Systems Biology Markup Language. This will also help to have standardized maps that can be used by other people. However, while your map is now readable by computers, it is not best suited for visualization. That is why we can use another tool, that is the Minerva platform, to visualize the map. Minerva allows you to easily zoom in, zoom out, a bit like in Google Maps, and we will show you how it looks like in the next part of this video. Finally, Minerva is also suited for reviewers and domain experts to make comments. Based on such feedback, we can update the map and then restart the cycle. Let's have a look at one of these physiological maps. We are here with a physiological map on the Minerva platform. As you can see, you can easily navigate through the entire map and zoom in or zoom out on the different pathways of genes of interest. But Minerva is actually much more than a visualization tool. You can, for example, get more information on a specific node by simply clicking on it. Information will appear on the bottom left. A legend is also there with the meaning of all symbols, and it's available. And you can add comments by just simply right-clicking on a node. If you would like to know more about how to use this platform, we will also soon release a tutorial on Minerva. In Ontox, the physiological maps represent a first step towards the establishment of what we call ontologies. Ontologies are defined in the Ontox project as frameworks that will qualitatively and quantitatively gather and integrate relevant biological, toxicological, chemical, and kinetic data from various sources. In other words, in these ontologies, physiological maps constitute the biological layer on top of which other information and data will be added. Not only do physiological maps represent the foundation of ontologies, but they are intended to be used to benchmark adverse outcome pathways, or AOPs, possibly filling gaps and identifying new key events. As they graphically integrate information from multiple sources, the physiological maps can also be used for understanding complex biological systems, and in particular, how the components of a biological system interact with another, and how these interactions give rise to the emergent properties of the system as a whole. It can also be used for visualizing omics datasets, including your bone data, for example, and more practical information will be provided in the following tutorials. It can also be used for identifying potential targets or biomarkers for disease, and also for simulating the behavior of biological systems under different conditions and predicting how changes in one component of the system will affect the behavior of the system as a whole. And plus, well, we believe that physiological maps can be a very interesting educational tool that could be used for teaching, for example. Don't hesitate to visit the Ontox website for more information on the whole project. And if you have any questions, in particular on the development and use of physiological maps, please send us an email. You will find all the links and contact information in the description of the video. Thank you for listening. We will come back soon with tutorials on the tools we briefly introduced in this video.